Good morning, guys. We're going to go ahead and start our lesson today and start with the I can statement. Our I can statement is I can add and subtract fractions with unlike denominators. We'll be showing a couple of examples on this first slide. We'll focus with addition here, and then we'll do another video here in a second with subtraction. So you'll have a couple different things to reference when you're working on your problems. Okay, our first problem is 3/4 plus 5/8. It's probably a good idea most times when you start these to go ahead and kind of estimate to get an idea of what the answer might be or what it might be close to. So I know 3/4, we're getting closer to 1. That's 75%, and this is a little bit bigger than half, 5/8, because 4/8 is half. So I know my answer should be over 1 when I get done, again, to make sure my answer makes sense as I'm working through these. We need to find this unlike denominator. When they're unlike, we need to get a common denominator to add common sized pieces. What happens if we don't? A common mistake is some people just add across and they end up, if you would do that, for an example of what not to do here, if we just add and you get 8/12, if you just add up 3 plus 5, add the numerators and add the denominators, my answer comes up less than 1, and we just estimated and realized that isn't what it should be close to. So again, showing kind of what not to do there, mistakes that kids make still sometimes. Okay, so we need to get a common denominator. So here we have a 4 and an 8, and we want to get the denominator to be the same. You can use multiples to find that. A lot of times you can just count by 4s or 8s. So the multiples of 4, and I can just do this mentally, would be 4, 8. And the first multiple of 8 is 8. You could count to 16. You could use a lot of different common denominators, but we like to use usually the smallest one we can find because that keeps the terms lower and easier to work with. One thing you don't probably want to choose is 4, because if you start choosing the smaller one, then you have to divide to get things in simplest form. You don't always get whole numbers. So usually you try and pick the larger one. So 8 would be a good common denominator here because 8 is a multiple of 4 and 8 is a multiple of 8. So I'm going to stay organized here, and I'm going to change my denominators to both have an 8, and then I can add them up when they're the same size pieces. This one's already an 8, so 5/8 can stay the same. Now to get the 4 to change to an 8, I know I need to double that, okay? And that gets an 8, and then when I do that, I also must double the top and take it times 2. Okay, and the reason we do that, guys, whatever you do to the bottom, you must do to the top. If you look at 2 seconds, or 2/2 there, that fraction equals 1. And we know from our identity property, anything times 1 is itself and keeps the same value. Okay, so 3/4 times 1 is still actually equals 3/4. We're just changing the terms. Okay, so in this case, it would change to 6/8, which we know in simplest form is 3/4. So when I've got that completed, now I've got that common denominator, 6/8 plus 5/8. Now, when they're the same size pieces, we're in 8ths, we keep that denominator the same, and now I can add those numerators, and I now have 11 of those 8ths, and I know that's greater than 1. So my estimate is making sense here. Some people keep it in that form. Eventually you'll want to get it to simplest form. And again, if we're in 8ths, you know that 8/8 equals 1. So a lot of people can do this mentally, and they know 8/8 plus 3/8, that equals 11/8. Okay, so we know if 8/8 is 1, you can just change this to 1. So actually 11/8 is 1 and 3/8. Some people like to follow kind of an algorithm. They know this means to divide. So I could take 11 divided by 8, and I could do quick division and know I can get one group of 8, which is 8, and subtract, I get 3. So I have 3 left, which means I can not get another group of 8. So I like to teach divide and make a V. So a lot of kids will make a V here type shape, and they know we have one full group and we have 3 left at another group of 8. So we would write 1 and 3/8. Okay, so that's one example of adding with unlike denominators. And this answer in this case comes up to 1 and 3/8. Okay, we're going to take a look at one more example here where it might look a little different. Okay, sometimes you might have an improper fraction or a fraction that's greater than 1. So let's look at this example. 1/3 plus 5/4. Okay, and again, if I look at this, I probably want to start estimating. I know this is slightly greater than 1, and this is 1/3, which is less than a half. So my answer is probably going to be 1 something. Probably not get to 2. So again, just kind of setting the tone for making sure my answer is going to make sense. When I look at my denominators this time, I have a 3 and a 4. And in this case, if I list their multiples, and if you just know your facts, and sometimes you can just multiply these two together and you're going to get that least common denominator, so you keep the terms smaller. So I could count by 3s, 3, 6, 9, 12. And I could count by 4s, 4, 8, 12. And I can see that they can both get to 12. So that would be a good common denominator to use. So I keep the terms low. I use that lowest common denominator. In this case, neither one of them can stay the same. They're both going to have to change to get them to a 12. So I'm going to have to use that identity property with both of them. So if I look at 1/3, I got to think to myself, what do I do to that 3 multiplicatively to get it to 12? And in that case, I know I'm going to take it times 4, because I got to do that multiple 4 times. So I also must take the top times 4, and then again, that equals 4 fourths. So I'm just taking this times 1, so the value stays the same. And if I do that, I find out that 1/3 is equivalent to 4/12. And in this case, now the 4, I've got to get it to 12 also, so I need to take that times 3 to get it to 12. So take the top times 3, and 5 fourths times 3/3 is 15/12. So now I've got the same size pieces. So now I can add them together and see how many total pieces I have. And in this case, I'll end up with 19/12. Again, some of you mentally can just look at that and know 12/12 is 1. So that gives me 7 more 12ths. Or I can divide and make a V and do my 19 divided by 12. Remember, the fraction bar can mean divide as well. Okay, and I get one group of 12 with 7 left over. So if I make my V, I've got 1 and 7/12 would be that answer in a simpler form. Okay, in the simplest form, which is a little bit easier to understand than 19/12. Okay, they may also, sometimes you might see 1/3 might be written, or excuse me, this problem could be written 1/3 plus 1 and 1/4. And 1 and 1/4 is the same as 5 fourths. Okay, I could change this to 5 fourths and the work would be exactly like I have it here. Or I may decide I want to do it in a little different way, because we know in adding, we could do something like this when we're dealing with addition, 1 and 1/4 plus 1/3. Okay, and I could line up my fraction and my whole number, and I could do similar work here in this case. The fraction, I'd have to get a common denominator. I'm just going to add these fractions first. So we know 1/4 changes to an equivalent fraction. If I take it times 3/3 again, this time I get 3/12. And this denominator also needs to change to a 12. So I take it times 4 and the top times 4. Again, that identity property. And that changes to 4/12. So now I can take my 12ths and just add them. 3/12 plus 4/12 is 7/12. And then 1 plus, we have no whole number here. We get 1 and 7/12. So we get the same answer. Again, you can kind of work it different ways sometimes, but they're the basics of adding fractions with unlike denominators.